A very good morning to one and all. I am Dr. Mahesh Kumar Yenki, Vice Chancellor of G.H. Raisoni University, Amravati. I am going to talk to you today about institutional emergencies, under which I will cover chemical emergencies, the United Nations classification of hazardous chemicals, lab safety and risk reduction. Friends, wherever you are, just have a look around yourself and try to point out anything which is not a chemical. I am sure you are not able to point out this, because everything surrounding us is a chemical. Chemicals are integral part of human life. They have invaded all the sectors of our life. They have definitely made our life more comfortable. The food we eat, the water we drink, the medicines we take, the cosmetics we use in our day-to-day life are all chemicals. However, the very same chemicals which have made our life comfortable possess certain inherent dangers. We say no chemicals are totally safe or non-hazardous, but there is only safe way of handling them. We have to handle chemicals safely. If you look at this periodic table, it consists of certain number of elements. The list is around 111, 112, it's increasing. But chemistry is about innumerable number of chemicals which can be formed due to the interaction of these elements. The list of chemicals is increasing at a rate of around 8,000 new chemicals per year. That makes it around 20 chemicals per day, because the research and development is continuously going on. And out of these chemicals which are prepared, they can be non-hazardous to extremely hazardous to the catastrophic hazardous level that we only come to know after analyzing them, after knowing about them fully. The dangers which are associated with chemicals are not only at the site where they are produced. In fact, it starts right from the site where the raw materials for producing these chemicals are stored. The dangers can be at the production site. It can be at the storing facilities where it is stored, and also during its transport from one place to another place. You may not be living in a close vicinity of a chemical industry, but the thumb rule says that we are always within a distance of 5-kilometer radius from a chemical disaster, because chemicals are transported on the same routes on which me and you travel. And therefore, we have to handle them very, very carefully. Another important aspect of chemicals is they behave differently under different ambient conditions. Under one condition of temperature, pressure, the chemical may look perfectly safe, but the moment ambient conditions changes, its properties may undergo certain change and make them hazardous. They may interact with other chemicals and their physical and chemical properties will change. The product of two non or less hazardous chemicals can be an extremely hazardous chemical. During our day-to-day life, we are making use of bleaching powder for water treatment in our overhead tanks. We are also using certain acids for cleaning the toilets, and these chemicals are in our household. But by mistake, if they get mixed, you can have a very hazardous product, that is chlorine, which is extremely toxic gas, and it can cause fatal injuries to death. Similarly, vice versa is also true. We can have products of two hazardous chemicals as a non-hazardous or less hazardous one. A good example will be sodium and chlorine. because chlorine is a toxic gas, poisonous gas, sodium is a metal which is highly reactive, and if it comes in contact with water, it will catch fire. But if these two chemicals, the product will be sodium chloride, which we use in our day-to-day life. So, we say that we, as the first precautionary measures, chemicals should never be stored alphabetically as per their names, but in groups which do not interact with each other. We can keep one group of chemicals and the neighboring group such chemicals which do not interact, so that in case of some incident, some accident, there should not be any reaction leading to further complications. Chemicals reactions, normally the chemicals will occur in three states: solid state, liquid state, and gaseous state. Solids, while melting, will get converted to liquid. Freezing is a reverse process where liquids get converted to solid. Liquids will vaporize as the temperature increases to gaseous state, vapor state, and vapors or gas will get condensed to liquid state, and this process goes on in nature. The chemical transformations which are occurring may be reversible, may not be reversible. We call them as irreversible processes. And all chemicals, they will be occurring with evolution of heat, which we call as exothermic processes, or by absorption of heat, which we call as endothermic processes. A simple example which I can give, the LPG gas which we use for the purpose of cooking, when we burn it, when it undergoes combustion in the presence of oxygen which we get from ambient air, lot of heat is evolved, and this heat we use for the purpose of heating or cooking. That is an exothermic process. When you add common salt to ice, the temperature will drop further down, which we call it freezing mixture or making ice cream. That is an endothermic process. So, all these chemicals which are around us, they become hazardous the moment they enter into our body system or we come in contact with them. There are mainly three routes by which these chemicals can enter into the human body. First is breathing or inhalation. Second, skin or eye contact. Human skin is porous, and therefore it is not safe against chemicals. Chemicals can enter through the pores, can enter into the body system, and once it enters into the body system, it will show its adverse effect. Third way is swallowing the chemicals or their ingestion. This can happen when chemicals have spilled or settled onto our food, beverages, cigarettes, and so on. And this way, if they enter into our body system, again they will lead to its adverse effect, which initially a feeling of uneasiness will be there, nausea, vomiting, breathing problem, flow of tears from the eyes, and then these primary symptoms will get more and more complicated depending on the amount of exposure. If we are exposed to a higher concentration, the results can be even fatal. It can cause death. And depending on the several properties of chemicals, the classification is done, or hazard classification of these chemicals, which is as per the UN classification, which I am showing you now. There are other systems of classification also, like National Fire Protection Authority, OSHA is there, and so on. There are, but this general one which I am showing you today is UN classification or of hazard classes and divisions of chemicals. In class 1, we consider explosives. The class 1, these are those chemicals which explode, releasing lot of energy, heat, shock waves which cause the destruction. The explosives or the class 1 chemicals are further subdivided from mass explosion, which is 1.1, to 1.5, which is very insensitive explosive, like which we use in Diwali festival or crackers. The class 2 chemicals are compressed gases. Further, you can have gases, compressed gases which are flammable, which are non-flammable, which are toxic. So, that is further subclassification. Class 3 of chemicals are flammable liquids, class 4 flammable solids, class 5 oxidizers, class 6 poisons, class 7 are radiological, class 8 are corrosives, class 9 are other regulatory materials. However, one who knows chemistry will be able to make out from this chart, but for the sake of even a common person should identify that particular chemical, we make use of placards or symbols. This chart shows the 9 hazardous classes of chemicals and their subdivision, as I have already told, explosives 1.1, 1.2, 1.3 and so on. And then the placard, the orange colored placard which we use for showing explosives. For gases, it is the green color and so on, as can be seen from this chart. Class 1 explosives, as you can see, it is an orange colored placard. It is mentioned explosive, there is a symbol of explosion, and its 1.1 means it is a mass explosive. If it is 1.2, the intensity is going down up to 1.5, where it is an insensitive explosive, or as I said, we use during festival season the crackers. Class 2 are gases. The green color placard would mean that it is a non-flammable gas. It will not catch fire. The second one is the red colored placard, which is flammable gas. I think you can immediately think of the LPG cylinder which we are making use at our homes. The color is same, that is a flammable gas. On the white placard on which you can see the skull and bone symbol, that is death, that is poisonous gas. Now, if I am seeing a cylinder of chlorine gas, you will find the cylinder is green in color because chlorine is not flammable, but then on that you will also see a skull and bone arrangement showing that it is a non-flammable gas, but it is toxic or poisonous. The flammable liquids, again the red color, it's mentioned combustible, means it will burn in the presence of oxygen and if fire is there. Flammable solids, it is white and red stripes, spontaneously combustible material. That means at a certain temperature it will catch fire by. Good example of that would be if you mix glycerine with the potassium permanganate, the reaction is so exothermic that it starts vigorously and temperature rises and it reaches a temperature which we call as auto-ignition temperature and it catches fire. Blue colored placard, it is dangerous when wet. That means if you see this placard, those chemicals should never come in contact with water, because then the moment they come in contact with water they become dangerous. An example is all alkali metals, sodium, potassium, rubidium, cesium, francium, lithium. Of course, we start with lithium, sodium, potassium. All these, the moment they come in contact with water, lot of hydrogen is evolved, process being exothermic, lot of heat is evolved, then it catches fire. And the reactivity increases as we move down this group. You can simply, now we have this information highway, that is internet. You go to Google, type reaction of alkali metals with water, you will get very good clipping showing what happens. What do we exactly mean by increasing the rate of increase of reactivity? It is several folds, unimaginable. So, similarly calcium carbide, if it comes in with contact with water, you get acetylene gas, which the welders on the roadside you can see are using for the purpose of welding. So, chemicals are very useful, but if they are not handled with due care, due respect, then they will ultimately prove very, very dangerous. The spontaneously combustible material, I already talked on to this, dangerous when wet. The yellow colored placard is about oxidizers like hydrogen peroxide, let us say ammonium nitrate and so on. They will release oxygen, and oxygen helps in burning. So, these are oxidizers. Poisons are shown by this placard, that is toxic with skull and bone arrangement. Sometimes the placards are more explanatory. They will also mention inhalational hazard or contact hazard and so on. And the third one, where you can see a kind of crab, that is infectious substance. Normally they are the biological hazards, where you have viruses, bacteria and so on, which are infectious. That is, from that we can get infection. Poison, again the same thing, inhalational hazard. This symbol you will see on all the vehicles carrying medical waste. It is biohazard, biological hazard. Radiological hazards are shown by a placard with a black colored fan on a yellow background. Corrosive substances like acids and bases are shown by this placard, black and white, where you can see that the substance is very, very injurious to the skin. It will also affect the metals and so on. So, these are normally acids and bases. The miscellaneous hazardous materials or other regulatory materials, which we call ORMs, they are shown by a placard with black and white stripes onto it. As I said, there are number of systems by which these substances, classified substances are depicted in the form of placards, but now to make the system more convenient, globally harmonized system GHS is developed by United Nations, and India is also signatory to this GHS, and a common system will also be there soon. I would particularly like to take your attention towards other regulatory materials, which include things like dust, normal dust, cement dust, the dust from stone quarries, from the cotton and textile industries, which normally is considered as a very clean industry, slate industries, asbestos industries and so on, because the fine dust particles, depending on their size, becomes extremely dangerous. If the particle size is 18 to 20 microns, they get blocked at the nose, which acts as a filter. If the particle size is further less, 15 to 18 microns, then they get blocked in the throat. You may get itching, and then they get removed from the body system. Further smaller particle size, they go right up to the lungs, and further smaller 4 to 6, they can go up to bronchioles, and 1 to 5 alveoli. In fact, this 5 micron and below size is extremely dangerous, and that causes slowly breathing related problems. This effect is little slow, and over the years, if people are continuously working in this atmosphere, we will find that over the years they start showing the problem of breathing related problem. This is a picture where you can see the person working in a textile industry protecting the breathing passage with a simple cloth filter, which is extremely effective. We cannot neglect this precaution. Here the people are working in the stone quarries. They are without any protection, and therefore they are exposed to the danger. This picture shows that after working for 5 to 7 years, slowly the lungs, their capacity decreases, and they start suffering from silicosis. This percentage is extremely large in India. In fact, if you look at the problem of silicosis in quarries, it is mostly 18 to 20%. There is one place in Andhra Pradesh called Munrela Thanda. That name means Vidwao ka gaon, the village of widows, because the men folk working in these quarries, their average age is 35 to 40 only, because they start working at a very young age, and after working for 7 to 8 years, they start developing these problems, and by the time they are 35, 40, they die due to these problems. The precaution is very simple. They must use a filter, but many times this is neglected. To know why the chemicals, when the chemical will become dangerous, we should know certain basic properties, basic definitions of the chemicals, which I would like to show in short. One is vapor density, because as I said, chemicals are affecting our bodies adversely if they enter into the body system, and then there are three routes. So, vapor density is the ratio of the mass of a given volume of vapor to the mass of equal volume of air under the same temperature and pressure. If the particular chemical in its vapor state is heavier than air, it will lie low, it will touch the ground. If the chemical vapor is lighter than air, it will go up. For example, ammonia being lighter will go high up in the atmosphere. Carbon dioxide, methyl isocyanate being heavier than air, chlorine heavier than air will lie low on the ground. Knowing these properties will help us to safeguard ourselves. Flash point, it is the lowest temperature at which an inflammable substance gives off sufficient vapor so as to form a momentary flash on application of pilot flame. In fact, for fire there are three things which are important. We must have a fuel, oxidant, which is mostly oxygen, and fire. But even if I have fuel and oxygen, they will undergo or give a flame only if the composition is in certain range. And therefore, when the temperature increases, the substance will vaporize, concentration of vapor will increase, and it will reach a point where when we show a flame, oxygen is already there in the ambient conditions. So, the moment I show a flame, it will give a flash, that is a flash point. And the second is fire point, which is slightly above flash point, means further increase in temperature, the concentration of the vapors of that particular chemical becomes so high that now it will give you a continuous flame, it will burn continuously. So, fire point is generally above flash point by 1 to 2 degree. Ignition temperature, it is the lowest temperature at which a spontaneous combustion can take place without application of an external heat. Means we go on heating the substance to such a level that it will catch fire by itself. And this data is also available in standard books, firefighters handbook and so on. About density also we should have some idea. Density of a substance is its mass per unit volume, and density of water we take as 1 gram per centimeter cube or 1000 kg per meter cube. If you look at water, mercury, its density is 13.6, it is 13.6 times heavier than water. If a substance is lighter than water, it will float. If it is heavier than water, it will sink. Similarly, relative density or specific gravity will give you an idea that the ratio of mass of any volume of a given substance to the mass of an equal volume of water. And if the specific gravity is less than 1, the substance will float. If it is greater, it will sink in water. Likewise, I already said that if the vapor density is less than 1, the vapors will rise when they are released in the atmosphere. vapors will seek to lie low if its vapor density is greater than 1. The chemicals which we use at home also, acids and bases. Permanganate we use for purification of water, salts we use burners, we use bleaching powder, we use insecticides, and for protection of grains also we use some chemicals, mostly sometimes very small dose of organophosphorus compounds which are extremely dangerous. So, due care should be taken when we are making use of these chemicals. Such charts showing all the important properties of any substance are also available in standard books, on internet, on firefighters handbook. I will be showing you a chart for ammonia which gives very important properties like its boiling point, its relative density, its vapor density, and so on. Its uses for which the chemicals are used, this particular chemical is used, the properties of fire, whether under what conditions it will catch fire, the health hazard it will cause, the route of exposure of this chemical which is inhalational, then the chemical dangers associated with this particular chemical, and whether it is heavier or lighter than air. So, if we are working or we are in the close vicinity where such chemicals are being used, having an information like this will be very handy, very useful for reducing the risk at the time of certain emergencies. To safeguard ourselves, we should also look at the weather conditions at the time if some untoward incident happens, because the effectivity of the chemicals depends on weather conditions also. If the temperature is very high, then the vaporization of the particular chemical will be very rapid. The vapors will rise depending on its vapor density or will seek to lie low. But this vaporization rate will be very high, therefore, a high concentration will be there, plus this concentration with time will decrease because the hot gases will go high up in the atmosphere, the dilution will be fast. So, vaporization will be rapid because of the temperature, dilution will also be there. If the temperature is less, then the gas vaporization of that material will be very slow. So, we will have a higher local concentration, means around the, if the chemical is spilled and then temperature is low, then vaporization will be less rapid, but in the vicinity of the spilled chemical there will be high concentration of this chemical. The wind velocity also plays a very important role. If the wind velocity is very high, then the gas or the vapors of this subchemical will spread in the atmosphere at a very rapid rate. So, the effect will be over a larger area, but for a shorter duration, because simultaneously the gas is also getting diluted, its concentration will reduce and it will go below the hazard concentration level. If the wind velocity is very less, then the high local concentration will be built. So, the effect will be over a smaller area, but for a larger duration. Wind direction also we should always take care of. We can in fact hit the dust and then see which direction the dust is going. This way you can make out in which direction the wind is blowing, and we should always go against the direction of the wind if we encounter such a situation where there is some accident, some chemical has spilled and it is getting vaporized. So, we should always go against the direction of the wind so that we are protected from this chemical. At home, as I said, we are making use of many chemicals, several chemicals. The LPG or liquefied petroleum gas which we are using for cooking purpose has really made the life of the housewives very comfortable, but due care has to be taken. The cylinder is designed for certain amount of gas at a certain pressure which is in liquefied state. It is isobutane which is odorless, colorless, and therefore, if there is some leakage you will not be able to make out. So, purposefully we add some pyridine which has a very strong smell, and if the and this chemical is just added in case there is a leakage in the cylinder, I will be able to make out due to the smell of that gas, pyridine. Now, the cylinders, there is a regulator. The regulator also must be fitted properly, and whenever we are using, we put on the knob, and after the use it should be properly put off. The cylinder is always kept in a vertical position. There are people giving funny ideas like when the cylinder is almost about to become empty, then if I make it horizontal, then I can make use of those last traces of gas which are present in the cylinder. I will suggest one should never do that, because that small amount of gas, the cost which we will be saving probably is not worth the precious life of the mankind. Similarly, the cylinder should not be directly kept in sun so that the temperature will rise, because it is the design is such that it will withstand up to quite a temperature, higher temperature and pressure. But if it is not handled properly, this leads to the gas cylinder explosions which we sometimes read in the newspaper. If we take due care, this threat can also be avoided. So, friends, chemicals no doubt are very, very useful. They will be there with us because human body itself is made up of chemicals, and we have to give due care, take due care, pay due respect to the chemicals and safeguard ourselves by proper knowledge, by proper care. So, in this lecture we have learnt about the chemicals, their certain basic properties, and based on these properties how they are classified, how they are depicted in the form of various placards so that everyone will be able to identify them, and how they enter into our body system and causing the risk to the life. Also, how the particle size of this other regulatory materials affect the body in the form of because there is a direct relationship between particle size and infectivity. So, thank you very much.